Hi everyone. Welcome to the Friction Lab for Earthquakes and Seismology. So, what I have here, we have our equipment. So, our wooden block is attached to a string, paper clip, and our elastic band, which can actually stretch. We have a string here attached to a cylinder, which we can pull with two hands and be able to pull this wooden block along this kind of custom-made kind of sandpaper surface, which will add some friction to the experiment. Friction is a force created when two surfaces or two materials move past each other, rub together, and friction can be work against movement and slow things down. So, in terms of earthquakes, now an earthquake is a sudden release of elastic energy that has been trapped inside rocks, inside the crust, and has been created by convection currents adding the stress or force to the rock by movement, and the stress turns into strain and deformation, how to be stretched or squeezed or pulled in certain ways, the rocks. And once the rock breaks and forms a fracture, there's still movement around the fracture. We call that a fault line. And the fault line is where the earthquake occurs, right? So somewhere along that fault line, whether it be shallow or deep down under the crust, there'll be a point where the earthquake occurs, and that's called the focus, okay? So the earthquake will be demonstrated here in this crude experiment. And we're going to have one person move the block or pull the block across the sandpaper like this. And one person's going to time it. One person's going to also going to measure how far that block moves. So if I move the block, every time it moves, it's going to move a certain distance. And that is called displacement. And we have here a nice little measurement in centimeters from 0, 5, 10, 15, 20. So we can measure how far the block is moving each time during the course of the experiment. So this is our data table, which you have online on your document, and it has 3 trials, so 3 attempts, and it has the different sandpaper grit levels. So this one is 60, which is the roughest or coarsest, and there's also 100 and 2000. 2000 is very smooth. So you might see a difference in the grit level and how the block moves across and how far the displacement is. What we're looking for is you to add or enter in the distances that the block moves over the course of time in the experiment. If the block sticks, if it sticks and doesn't move, but I'm still pulling, okay, this shows you, this is like an example of the crust or the rocks getting stuck together along that fault line, and the convection currents keep adding stress and movement to the rocks, but they're still stuck. Well, over time, the stress will build up to a point or a threshold where it's too great or too much, and then the plates will slip. And that is shown in our dip slip faults or our strike slip faults, where the one side is going to move or jolt forward, and that is called displacement, and that is where the release of energy comes in. That's where the earthquake actually occurs, at that focus point along the fault line where the movement is. So this block's going to stick and then jump forward, just like we do in the crust. Now, for the experiment, I like to add some weights. So I have these little 200-gram weights, and I add 5 of them. So that's a kilogram or 1,000 grams. And that basically means that as more weight, more mass or gravity pushing down onto this sandpaper. So as I try and pull it across the wood, you're going to have a lot more friction, a lot more difficulty in trying to do it. So what happens is eventually it's going to jump forward, and that may happen. So you might have too much weight. So maybe only use 1 or 2 or 3. But you can change that, but make sure that each trial you have the same amount of weight on. So there. So I'm just going to keep moving it, and it jumps, sticks, then it jumps forward. So that's exactly what happens in the crust, where it sticks, and when it jumps forward, you have your earthquake. You have your release of energy, and that's your earthquake. Okay? So do this with different grit levels, working groups where one person's doing the experiment, one person could be holding the wood, one person could be holding the timer and doing the measurements as well.